Hello everyone. Today I want to talk about Kubernetes. This video will be a very quick guide for anyone who wants to use Kubernetes. I will try to discuss important concepts in a simplified form so that they're easy to follow. Use this video as a starting point to learn about Kubernetes, but you might want to dive deeper into specific details after this one. So let's start with what is Kubernetes. Kubernetes is an open source container orchestration platform that helps with deploying, managing, and scaling containerized applications. It helps by automating manual processes needed for all of these tasks. You will need to provide some metadata and configuration for your deployment, and Kubernetes can deploy your containers. It can monitor and scale instances as traffic grows. It can also restart your instances if they crash. And because Kubernetes is really just deploying containers, mostly Docker, you should also have some understanding of Docker to be able to use Kubernetes. When we talk about deploying to Kubernetes, we are really talking about deploying to a Kubernetes cluster. And Kubernetes cluster is just a group of servers with Kubernetes setup and running. This is a very simplified architecture of a Kubernetes cluster. We do have a control plane where Kubernetes core is hosted. Control plane is how you interact with the cluster. Also, control plane has all the Kubernetes core components which are required to manage all the nodes in the cluster and all the containers that are running in this particular cluster. On the other hand, nodes are the servers where your containers would actually be deployed. There are some Kubernetes core components deployed to each node, so control plane can talk to these nodes, but most of the compute and resources are provided for your containers, and you can use the nodes to deploy your containers. To define what to deploy, you need to provide some metadata and configuration. This is specified using Kubernetes manifest files. These manifest files are mostly YAML files that allow you to define the desired state. And once you have a desired state, Kubernetes will try to get to the desired state. So let's look at a manifest file to understand better. This is how all the Kubernetes manifest files look like. All manifests have API version and a kind. API version is really the version of the Kubernetes API where this particular object is available. Kind, on the other hand, is the type of the object, kind of the object that you want. Next, we have the metadata block. This is where you define all the non-functional details about your Kubernetes object, starting with the name that you want to use. Next, we have the namespace. Namespace is just a way to group together similar type of objects. For example, you can have a namespace called application1 and then put all the Kubernetes object for application1 in that namespace. And you can create other namespaces for other applications. Lastly, we have labels, which is just a list of key value pairs. Kubernetes does not expect any specific keys to be used here. So you can use any key that you want and then use them accordingly. We'll look at some examples of how labels are used later in this video. Moving on to spec, this is where you specify all the important details about your object. Unlike other parts of the manifest, spec is object specific. So it changes based on the kind of object that you want. So let's look at some different type of objects in Kubernetes and look at how their spec looks like. Starting with pod. Pod is the smallest deployable unit in Kubernetes. It can be used to run one or more containers, mostly Docker, and that is where the name pod comes from. Docker logo is a whale, and group of whales is called a pod, so that's what they named it. Pod is just a wrapper on top of containers. You cannot deploy a container directly in Kubernetes and instead deploy a pod, which indirectly deploys one or more containers. This is a very basic spec for a pod. On the very least, you would want to specify the containers that you want to run as part of this pod. In this case, I'm using Nginx container, and I'm using the Docker image defined in the spec. I'm also specifying some ports that are used by the container, though this is mostly just for documentation and isn't really used by Kubernetes. I also have an option to put in a command, which I did not use in this case because my Docker image already has the entry point that I want to use, and that's good enough for me. But if you want to override the entry point for your Docker file, you can use the command object and specify the command that you want to use. I also wanted to quickly cover init containers. Init containers are different from containers that we've mentioned up above because containers are expected to run forever and, let's say, serve traffic from your clients. On the other hand, init containers would run before the actual containers, and you can add any initialization logic as part of init containers, which will run before your actual containers. Most of the time, you would not deploy a pod directly. Uh, Instead, you would use something called a deployment. So let's look at deployment next. So deployment object is a wrapper on top of pod, but why do we need it? Pods are very basic unit that can be deployed, but has no native feature for scaling or update strategies. If a node crashes, so does your pod. Deployment helps by monitoring pods and making sure that required number of pod instances are healthy. If a node crashes, deployment starts the pod on another available node. When you have a new version, deployment can manage a rolling update. It can also scale number of pod instances as needed based on predefined rules, like when traffic spikes. Deployments to work through another kind of Kubernetes object called a replica set. We will not dive deeper into replica set today, but it is good to know how deployment works. Deployment will create replica set, which in turn creates required number of pods and monitors them. If you look at the API version for the deployment in the manifest, it says apps/v1. We've looked at other objects where API version was just v1. That was because they were part of basic Kubernetes API group. But in this case, deployment is part of an API group named apps, and that's why we have to mention that API group and then the version. That's the pattern that we use. This is how a deployment spec looks like. You would want to define number of replicas you want for your pod. And then we have selector. In this case, I'm using match labels to select pods for this deployment. And in the end, we have template. Template is just a copy of the spec and metadata that you would have in a pod. Uh, you just have to add that as a template here. And it's called a template because this is the pod template that deployment will use to create as many replicas of pods as needed. And notice that in the metadata section, we haven't really mentioned a name for the pod because we don't have to provide a name. Name is uh, derived from the name of the deployment in this case. So we've looked at pods and deployments, which will help you deploy your containers, but that isn't usually enough. And I say that because your pods are deployed, but if your containers serve traffic over the network, they are not accessible outside the pod. Each pod has its own internal network, and any API endpoint served by a container is only accessible to other containers in the same pod. So we need a way to expose specific ports which are used by your containers to serve traffic. So this is done through Kubernetes object of kind service. Each service can point to multiple pods, mostly replicas of the same pod. As these pods scale up or down, service would direct traffic to only pods that are live. So it does work as a load balancer of sorts as well. Looking at the API version, we just need to mention v1 because service is part of the basic Kubernetes API group. Let's look at this spec. We need to specify the pods that the service should point to, and we do that using selector. In this case, I'm using the label app with the value of nginx, so all the pods which have this particular label will be pointed to by the service. Secondly, we have ports. You can provide a list of ports here. For example, I've only used one here. You will have to specify the protocol, usually TCP or UDP. Target port is the port that your container is serving traffic on. Port is the port where the service will be exposed within the cluster. On the other hand, node port is the port where the service will be exposed at the node level. So if you use the IP of your node and this port, you will have access to this particular service. Versus in case of port, it will be accessible only within the cluster. And we usually mention just one, either port or node port for a service. If we mention a port when service is only accessible within the cluster, you redirect traffic to the service from outside the cluster using something called an ingress. On the other hand, if you specify the node port, you may have used a load balancer outside the cluster to redirect traffic to these particular ports on node level. So we've looked at manifest files for Kubernetes, but how do we use these manifest files? How do we interact with Kubernetes cluster? So when we look at Kubernetes cluster design, we see we have a control plane, and that exposes APIs that can be used to interact with Kubernetes. There are some available UIs that help you interact with the cluster, but mostly this is done through Kubernetes CLI called kubectl. kubectl provides a very intuitive interface to interact with your cluster. Let's look at some useful commands provided by kubectl. So you can use kubectl apply -f your manifest file, and this will create or update the object that you have in the manifest. You can also use kubectl create, and this will create the object that you have in the manifest file, but if that object already exists, then this command would fail. Similarly, you can do kubectl replace, and in this case, if the object does not exist, this command would fail. Otherwise, it would just replace or update the object that you have. Lastly, you can do kubectl delete, which will delete the object that you refer here. If you look at the second delete command, it does not mention a manifest file like the other commands. This is an imperative way of writing a kubectl command. When we mention a manifest file, those type of commands are declarative because we are declaring the desired state in the manifest file and then using the manifest file to get to the desired state. Using declarative commands is preferred because you can check in these manifest files and keep track of the desired state in there, and you can provide this manifest file to Kubernetes anytime to get back to the desired state. So it avoids resource to drift away from the desired state. Let's look at some kubectl read commands. You can use kubectl get pods to get a list of pods deployed in your cluster. You can use the same command for any other object kind in Kubernetes, though this only provides you very basic information like status of your object. If you want more information, you can use describe. In this case, you have to mention one particular object of a specific kind, and then it will provide you all the information about that object, including its spec, its status, and any events that we might have for it. If you have issues with your pods running, you can look at the logs from your container. Maybe there's an error in there. Sometimes it helps to be able to SSH into the container and debug what's going on. This is because you have access to the same file system and network that your code has. So this command helps you SSH into a specific container in a pod. These are some very frequently used kubectl commands, but there is more to learn. I'll try to create a demo video covering more kubectl commands and link it here. But if you want to try kubectl commands and Kubernetes on your own, you can get started with something called a minikube. This will create a small Kubernetes cluster on your local machine, and then you can use it to play around. Thanks for staying till the end. That's all for today. See you in the next one.